Now, the next sub solution we have started with as a particular integral. So, as we have seen, the three methods are there for the particular integral: general method, shortcut method, and method of variation of parameter. Right. So, we have discussed in detail about general method to find the particular integral, isn't it? Firstly, we have discussed the formula of particular integral, which is 1 upon phi of d operated on f of x. And then the value of that 1 upon phi of d f of x we obtain with the help of general method. Uh, we have discussed in detail about the formula of general method, you can see. And later we have discussed the examples also depending upon the general method. So we have seen one note also. This method is generally used when the right hand side function is of the form composite function or the rational function or the inverse trigonometric function, etc. Right. This general method is applicable to all, but mainly if the right hand side function, which right hand side function, this one, if this right hand side function is of the form exponent composite function or the rational function, then we use general method. So we have seen several examples also, right? That is first, this example we have discussed complete solution. Hmm? Then the second also, which is a rational function of the form 1 upon 1 plus e raised to x. So we have solved this for the general solution. Hmm? And this was given for the homework. I hope everyone have tried this. So let us now proceed with the next method, that is the shortcut method. Okay. So if anybody want to ask any doubt regarding general method, they can ask. Any doubt? Shall we proceed with the shortcut method? Everyone please do reply in chat box. Shall we proceed with the shortcut? Everyone? Is there any echo or any background noise from my side? Hmm?
No, sir.
Okay, thank you. Fine. So there is no doubt regarding the general method. Hmm? So let us start with the shortcut method. So as I said, we're trying the particular integral of this homogeneous differential equation phi of d. Sorry, this linear differential equation of nth order, that is phi of d into y is equal to f of x. Right. So depending upon this nature of right hand side function, we have several shortcut formulas. For example, if this f of x is of the form exponential function, then we have a shortcut. If this f of x is a sine function or cos function, then we have a shortcut. If this f of x is hyperbolic function of this form, hyperbolic sine ax plus b, then we have a shortcut. Or cos hyperbolic ax plus b. If this f of x is a polynomial function, polynomial क्या होता है? Everyone knows. That is a relation in variable having the powers to be positive integers. That is called a polynomial, right? So if fx is a polynomial of this form, then we have a shortcut there. If the right hand side function f of x is a combination of exponential function, or if it is a product of exponential function and a function of x above, then we have a shortcut, that is e raised to ax into v. If this right hand side function is a product of x into v, where v is a function above, then we have a shortcut. And lastly, if this f of x is of the form x raised to m sine ax or x raised to m cos ax, then we have a shortcut, right? So if this f of x is one of this form, then we can directly have its particular integral by the formula. Clear to everyone? So let us discuss each of these sub case or each of these case in detail and its formula also. So the first is exponential function. When f of x equal to e to the power ax, like um, e raised to 2x or e raised to x or e raised to minus x or e raised to x by 2, etc. Clear? If the right hand side function is of uh, these forms, then we have a shortcut there. So let us discuss the formula first of all. See, we all know that when we operate d onto e to the power ax, what does it mean? Hmm? D of e raised to ax is derivative of e raised to ax, isn't it? And what is that? That is a e to the power ax, right? If we apply one more derivative, that is d square e to the power ax, what it will be? It will be a square e to the power ax. D cube e to the power ax will be equals to a cube e to the power ax. So if you observe this, then can we have in general the relation between these two? That is, we can write that d raised to n e to the power ax is e to the power a raised to n e raised to ax, isn't it? Or uh, if I apply 1 plus d onto e to the power ax, what it will be? Hmm? Will it be 1 plus a? That will be of the form 1 plus a e to the power ax. Yes or no? When I apply e raised to ax inside and by taking the derivatives, I'll get this. Yes or no? Or 1 plus d square of e raised to ax will be 1 plus a square of e raised to ax. Is this point clear? Hmm? Everyone? Hello? So what we're
Yes,
trying
yes.
to get, we are trying to get the relation between the function of d and function of a. So as we have seen, whatever the function of d we apply onto a raised to e raised to ax will be give in return the function of a that is giving the function of a in return. Yes or no? Whatever the function I'm applying in terms of d, I'll be getting function of a in return. So if I interchange these two, then I'll get the relation that is 1 upon phi of d. अगर मैं इसको राइट हैंड साइड में लेता हूँ, 1 upon phi of d into phi of a e to the power ax will be e to the power ax. ठीक है? And if I take this phi of a onto the right hand side, what I'll get? I'll get it to be 1 upon phi at d e raised to ax will be equals to what? 1 upon phi at a e to the power ax. Yes or no? Is this step clear? Provided that phi of a must be non-zero. तो यहां से मुझे फॉर्मूला मिल गया कि पी आई इक्वल्स टू, व्हाट इज द फॉर्मूला फॉर पी आई? पी आई क्या होता है? 1 अपॉन phi of d f of x, where f of x is here. What is f of x here? E raised to x. So 1 upon phi of d e to the power ax can be written as 1 upon phi at a e to the power ax. provided that this phi of a must be non-zero. So this is our formula for the particular integral by first case. तो what does it mean? इसका मीनिंग क्या है कि phi of d जो है उसमें हम क्या करेंगे to get the particular integral? We will replace this d by the coefficient of x in exponential function. जो a है उससे replace करेंगे. Clear to everyone? So here the main theme is replace that d by a. Hello. Is this point clear to everyone? Hello. I'm waiting for your reply. ठीक है. So you peoples are not interested even to reply. But anyways, if phi of phi of a is non-zero, then this will be the particular integral. If phi of a equal to zero, अगर phi of a zero है, then it is called a case of failure. If this denominator is zero, phi of a zero हो रहा है, then it is called a case of failure. And in that case, how do we write the particular integral? We write 1 upon phi of d e to the power ax, I'm writing here, then is equal to independent variable times. So what is independent variable here? It is x. So x times 1 upon derivative of denominator, that is phi of d ka derivative phi dash of d, right? Phi dash of d into e to the power ax. But phi dash of d में हम rule use करेंगे. What the rule is? Replace d by a. So what we will get here then? Phi dash at a e to the power ax, provided that this phi dash of a must be non-zero. Again, if phi dash of a is equal to 0, then what we get? Then 1 upon phi of d e to the power ax will be equals to x into one more x, that is x square, 1 upon phi double dash at a e to the power ax, provided that this phi double dash of a must be नॉन जीरो. सो जब तक मुझे ये डिनोमिनेटर नॉन जीरो नहीं मिल जाता तब तक मैं उसका डेरिवेटिव लेते चलूंगा. एंड I'll multiply by independent variables there, that much number of independent variables. Is it clear? So for example, if I have d minus 2 e to the power 3x, then what I'll do? I'll simply replace d by a there. So let's say d minus 4, suppose 5. Then by replacing d by a, what is a here? A is 3. So what I'll get? 1 upon 3 minus 5 e to the power 3x. So that is equal to minus 1 by 2 e to the power 3x. That is my final particular integral. Second example, if I have particular integral to be like this, d minus 2 the whole square e to the power 2x, then if you look at this, when I replace d by a, this d by a, then that will be a case of failure. Yes or no? That is a case of failure. So what we do in that case? we multiply by independent variable x into, we take the derivative of denominator, that is 2 into d minus 2 into derivative of d minus 2 is 1 e to the power 2x, and now into that we will use the case, that is we replace d by 2. But when I replace d by 2, I'll again get 0 there, so that is again a case of failure. So what I'll do, I'll further take the derivative, that is x into 1 more x into the derivative of this will be 2 only. Yes or no? E to the power 2x. And that is the complete particular integral pi equals to. Is this point clear to everyone? This is all about the first case. That is the main thing. Everyone, please do reply in chat box. Everyone. Thanks, Rucha. Whether he says yes. Dheeraj, Vedant, yes. Very good. So now इसमें एक्सपोनेंशियल फंक्शन में मेन थीम क्या है, आपको डी को रिप्लेस करना है ए से. So see, actually finding the particular integral means what exactly we are doing, we are eliminating, we are trying to eliminate d from phi of d. Yes or no? We are trying to eliminate d, and when we have completely eliminated d, that will be the particular integral. For example, anyways, we will discuss example after the discussion on complete method. So here there are three sub cases of this exponential case. Sub case 1, sub case 1 says अगर f of x एक्सपोनेंशियल फंक्शन है, लेकिन दैट इज एन एक्सपोनेंशियल फंक्शन ऑफ दिस फॉर्म a रेज टू x, ये भी एक एक्सपोनेंशियल फंक्शन है, राइट? सो हाउ डू आई राइट a रेज टू x in terms of e? Can I write this in terms of e? Hmm? Can I write in terms of e? Or is this correct? E to the power log of a to the power x. Is this correct? Can I write like this? And using the log
Yes, sir.
property, I can write further this as a e to the power x into log a. And if this log a I denote it by capital A, then what I'll get? I'll get it to be e to the power capital AX. So with this, if I want to write the formula of phi of a particular integral, that is 1 upon phi of d a raised to x, then how do I write? I can write this as a phi of d e to the power ax, isn't it? And I know the case for exponential function. What the case says? The case says replace this d by a there. So 1 upon phi at capital A e to the power ax, isn't it? Where phi of a must be non-zero. अगर ये zero आता है, then further we will take the derivative of this phi of a by multiplying the whole operator by independent variable. So what is a there? A is log log of small a. So 1 upon phi at log a e raised to ax, but e raised to ax is nothing but a raised to x. So this is my formula here, that 1 upon phi of d a raised to x can be written as 1 upon phi at log a raised to x. Clear to everyone? With the same thing, that if it is a case of failure, we go on taking the derivatives of denominator. Hello. So this is the sub case 1. Now the sub case 2 says, let me write in the next page. Sub case 2, it says when f of x is a raised to minus x. So first of all, let me write for the previous sub case that what is the main keyword there. Here what we are doing exactly, we are replacing dy d by log a. Yes. So in the first sub case, we replace d by log a in a raised to x. Okay. So on similar manner, we can do the same thing for a raised to minus x. So here the simple keyword is we replace d by minus of log a. If you do the same thing, we will get like this. So how do I write? 1 upon phi at d a raised to minus x can be written as 1 upon phi at minus log a raised to minus x, provided that this phi of minus log a must be non-zero. If it is equal to 0, then that will be a case of failure. So in that case, what we do, we take the derivative of this phi of d, and into that we replace d by log of minus of log a. Then the next sub case is sub case 3. It says if the right hand side function f of x is a constant function, exponential, hmm, that k can be written as k e to the power 0x. Yes or no? So
Yes, sir.
when I try to write the particular integral formula, that is 1 upon phi of d f of x, but f of x is k, then I can write this as we know 1 upon phi of d is an integration operator. I can write e raised to 0x. So I can write this as a 1 up k into 1 upon phi of d e raised to 0x. And then I know what should I do? I'll have to replace d by 0, isn't it? So what will be my formula then? I'm writing the formula here. 1 upon phi of d times k can be written as 1 upon phi at 0 times k. Provided that this phi of 0 must be non-zero. अगर वो भी 0 होता है, then we will do the same thing. We go on taking the derivative of denominator and we multiply by operator by independent variable. Is this point clear? So here the main thing is we are replacing d by 0 in case of constant. In case of a raised to minus x, we are replacing d by minus log a. In case of a raised to x, we are replacing d by log a. And in case of normal exponential function, we are replacing d by simply a. Everyone, please do reply in chat box. Is this clear? The first step. This is all about the exponential function. So let us have a simple example based on this method. Solve solve capital D square minus 5d plus 6 times y is equal to 3 e to the power 5x. So solve this completely. I mean solve it for the complete solution. So इसका complete solution क्या होगा? Complete solution or the general solution is the value of y as a cf plus pi. Yes or no? So to find complementary function, what we do? We consider homogeneous differential equation. तो क्या है homogeneous differential equation? Which is d square plus minus 5d plus 6 times y equal to 0. So to solve this homogeneous differential equation, we consider its auxiliary equation, which is d square minus 5d plus 6 equal to 0. And we find the roots of this auxiliary equation. So what are the roots here? D equal to
2 and 3.
2 and 3.
Comma
Okay.
3. Yes, sir.
Hmm? So as the roots are real and distinct, how do we write the complementary function? Hmm? Therefore, the complementary function is c1 e to the power 2x plus c2 e to the power 3x. Now to find pi, next sub solution as a pi, we start with the formula. We write the formula of particular integral. क्या होता है formula? Pi equals to 1 upon phi of d operated on f of x, isn't it? We substitute phi of d and f of x. So what is phi of d here? It is d square minus 5d plus 6, and f of x is what is f of x? It is 3 e to the power 5x. So as 3 is constant, I can write the outside the operator, that is 3 times 1 upon d square minus 5d plus 6 e to the power 5x. And what we do, what the case says for exponential function, we have seen 1 upon phi of d e raised to ax can be written as,
Replace D by A.
exactly, replace d by a. What is a here? 5, right? So therefore we get 3 into 1 upon 5 square minus 5 into 5 plus 6 e to the power 5x. So 25 minus 25 will be 0, and 3 by 6 e to the power 5x. So that will be 1 by 2 e to the power 5x. This is your particular integral. You can see the d, capital D, is completely eliminated. And therefore, we write the complete solution. Therefore, the complete solution or general solution is y equal to cf plus pi. We write the complementary function as a c1 e to the power 2x plus c2 e to the power 3x plus half e to the power 5x. Clear to everyone? Is this clear?
Yes.
Hmm? किसी का कुछ डाउट है तो पूछ लो प्लीज. Everyone, please do reply in chat box if any doubt. Hmm? Let's try one more. Only Manvi have given the reply. Very good. So let's try one more and then we will move ahead with the next case. Solve d minus 1 cube. D minus 1 cube times y is equal to e to the power x plus 2 to the power x minus 3 by 2. So before we discuss this example, let us discuss uh, of one formula which is required to solve this question. Suppose a is, I mean, the formula is, if we have d minus a the whole square, instead of square, let us take r e to the power ax. So what we'll have to do? We'll have to differentiate r, this d minus a raised to r, isn't it? How many times we need to differentiate? R times. Because R times it, that will be a case of failure. Yes or no? So when we go on differentiating, we will get one formula, because that much number of x we are going multiplying. So x raised to r, and in denominator we will be getting r factorial e to the power ax. So this is Very important formula we need there. 1 upon d minus a raised to r is equal to 1 upon d minus a raised to r e raised to ax is equal to x raised to r upon r factorial e to the power ax. And sometimes if one of the factor is a case of failure, like say d minus a raised to r, and there is one function, say psi of d, for which we don't have any problem. Like for example, आप देख सकते हो यहाँ, if I have pi equals to 1 upon say d minus 1 cube and d plus 2 raised to 5 e to the power minus 2x. So can you see this factor will have problem how many times? That will be a case of failure how many times? 5 times. But we don't have any problem to this factor. Is it clear? So
Yes, sir.
is this of this form? This is psi of d, for which we don't have any problem, but we have a problem at this d minus a raised to r. So how do we do for this? What we do, we replace d by a into psi. We will get 1 upon psi at a, and for the rest we will use the above formula, that is x raised to r upon r factorial e to the power ax. That's it. Clear to everyone? So these are the two important formulas which are very much useful in the competitive examinations also, like MCQ examination. So let's use that formula here. What we'll do? What is the complementary function here? CF क्या होगा? What are the roots here? The root is d equal to 1 1 1. Can you see from this? D minus 1 cube equal to 0 means d equal to 1 1 1, isn't it? So with this real and repeated root, how do I write the complementary function? CF क्या होगा? I'll start with c1 x square. See, most of the students have submitted wrong solutions for the complementary function. Homework I have given. Most of the students have submitted wrong solutions. But still, I have given the full marks only for the submission, not for the solution they have submitted. Okay. So c1 x square plus c2 x plus c3 the whole times e to the power x. Is this clear, everyone? Complementary function.
Yes, sir.
Now to find pi, particular integral, we write the formula pi equal to 1 upon phi of d f of x. So that is 1 upon, what is phi of d? Phi of d is d minus 1 cube. And what is f of x? F of x is e to the power x plus 2 raised to x minus 3 by 2. So I'll operate this operator over each of these functions separately. So that is d minus 1 cube e raised to x plus 1 upon d minus 1 cube 2 raised to x plus 1 upon d minus 1 cube into 3 minus 3 by 2. So we all knows that for the exponential function we replace this d by a. For
A
the a raised to x function we replace d by log a.
log A
And for the constant function we replace d by 0.
0.
Isn't it? So when I replace d by 1 in the first, that will be a case of failure. How many times? 3 times. So I can directly use the formula. What the formula says, 1 upon d minus a raised to r will be equals to what? X raised to r upon r factorial e raised to x. Yes or no? Plus, in the next, I'll replace d by log a. A is 2. So log 2 minus 1 cube. And plus, here when I replace d by 0, minus 1 cube will be minus, and minus minus will be plus. 3 by 2. Yes or no? So if you observe this, we have eliminated d completely, and therefore that will be a particular integral. Therefore the general solution is y equal to cf plus pi. So that is equals to cf, which is c1x square plus c2x plus c3 times e raised to x, and plus the pi, that is x cubed by 6 e raised to x plus 1 upon log of 2 minus 1 cube plus 1 3 by 2. Clear to everyone? Is this clear? Everyone, please do reply immediately in chat box. Everyone. Very good. So let us proceed with the next case. Yeah. So the case number 2 says when your right hand side function f of x is of this form sine of ax plus b, or it is of this form cos of ax plus b, then what to do? So let us get the formula first. We do the same thing if we operate d onto sine ax. क्या होगा? Derivative of sine ax plus b will be a cos ax plus b, right? If we take one more derivative, d square of sine ax plus b, what it will be? That will be a into cos ka derivative minus sine, and one more a, so minus a square sine of ax plus b. If we take one more derivative, d cube, क्या होगा? Minus a cube cos d raised to 4 will be minus minus plus a raised to 4 cos ax plus b. Yes or no? यहाँ तक क्लियर है सबको?
A
So,
raised to 4 sine, sir.
sorry, sine it is. That will be sine. So I'll write for this also uh, minus a cube into minus 1. So minus minus plus a raised to 4 sine of ax plus b. Right? So if you observe this, or I can write this d square as a d raised to 4 as a d square the whole square sine of ax plus b. And on the right hand side, I can write a raised to 4 as a minus of a square the whole square sine of ax plus b. Yes or no? If you go on taking derivatives, you'll be getting even order derivatives will be of this form minus a square and its power to be that order. Is it clear? So what does it mean that d square ka any power of sine ax plus b will be equals to minus of a square of that power sine of ax plus b. Is this point clear, everyone? Hmm?
Yes, sir.
So d square raised to p, or the functions of d square gives me the functions of minus a square. So I denote the functions of d square as a phi of d square sine of ax plus b will be equals to phi of minus a square sine of ax plus b. If I interchange the role of this operator, then I write the formula here then 1 upon phi of d square sine of ax plus b gives me 1 upon phi at minus a square sine of ax plus b, provided that this phi at minus a square must be non-zero. And this is the formula. सबको क्लियर है? So what the main thing here, what we are doing exactly, we are replacing किसको रिप्लेस कर रहे हैं हम? डी स्क्वायर को किससे? बाय माइनस टाइम्स ए स्क्वायर. It is not like this minus of a and the whole square. No, minus times a square. Hello.
Yes.
So that is what the thing here in case of sine, and the similar thing we can do in the in case of cos. Now this is a case where phi of minus a square is non-zero. Agar phi of minus a square 0 hai, then we will do the same thing as we have done in the exponential function. That is 1 upon phi of d square sine ax plus b can be written as x times 1 upon phi dash, and into that we will replace d square by minus a square sine of ax plus b, provided that this phi dash of minus a square must be non-zero. अगर ये भी zero होता है, then we go on taking derivatives still until we'll get the non-zero denominator, right? So that is what about the second case. I'm writing for the cos similarly. 1 upon phi of d square operated on cos of ax plus b can be written as 1 upon phi at minus a square into cos of ax plus b, provided that phi of minus a square must be non-zero. Is this point clear?
Yes,
Hello?
sir.
Now the point is, this case is mainly for the linear sine and linear cos. Linear matlab power of sine or cos to be 1. Agar sine and cos are not linear, then how do we proceed with this case? We have reduction formulas to convert those powers into linear form. For example, some additional formulas, let us write here additional formulas. The first formula is for sine square. What is sine square x in terms of linear cos? That is 1 minus cos 2x upon 2. So square getting into linear form, isn't it? So this I can write as a half minus half into cos of 2x, and then I'll use the case for cos. Done. The same thing for the cos square. The formula is 1 plus cos of 2x upon 2, right? If there is a product of sine and cos or sine and sine, like sine a cos b, what is the formula for sine a cos b? Hmm? It is half of, or 2 sine a cos b is sine of a plus b, plus sine of a minus b. So in this way, we can convert the product into linear sine. Similarly, sine a sine b क्या होता है? Is half of cos of a minus b minus cos of a plus b. Please correct me if I'm wrong. One more formula we'll be having cos a cos b. That is half of cos of a minus b plus cos of a plus b. Yes or no? Hmm? So these are the formulas, reduction formulas to convert linear, to convert the given function quadratic form or the product into linear sine or linear cos. Now here, the main theme is to replace d square by minus a square. ठीक है? But now the question is, अगर डी स्क्वायर है नहीं फंक्शन में फाई ऑफ डी में, देन सपोज इफ वी हैव डी क्यूब, देन हाउ डू आई रिप्लेस डी स्क्वायर? आई कैन राइट डी क्यूब एज अ डी स्क्वायर इंटू डी। ठीक है, तो मुझे सिर्फ डी स्क्वायर को रिप्लेस करना है। रिमेंबर, डी स्क्वायर रिप्लेस बाय माइनस ए स्क्वायर, इट डजंट मीन दैट डी इज रिप्लेस बाय स्क्वायर रूट ऑफ माइनस ए स्क्वायर। नो नो, हमें सिर्फ डी स्क्वायर को रिप्लेस करना है, राइट? सिमिलरली डी रेस टू 4 आई कैन राइट एज अ डी स्क्वायर इंटू डी स्क्वायर, तो दोनों डी स्क्वायर को मैं रिप्लेस करूंगा। डी रेस टू 5 कैन बी रिटन एज डी स्क्वायर स्क्वायर इंटू डी, तो मैं डी स्क्वायर को रिप्लेस करूंगा। क्लियर टू एवरीवन? नाउ द नेक्स्ट क्वेश्चन इज, अगर अगर डी है ही नहीं, मतलब डी स्क्वायर है ही नहीं डिनोमिनेटर में, लाइक 1 अपॉन डी प्लस 1, so how do I get that d square term in the denominator? If d square is not there, then rationalize the denominator. Clear to everyone? Denominator to get d square. Yes or no? अगर हम रैशनलाइज करते हैं तो नीचे डिनोमिनेटर में डी ए माइनस बी ए प्लस बी फॉर्म आ जाएगा, तो उससे हम ए स्क्वायर माइनस बी स्क्वायर लिख सकते हैं। हेलो, is this point clear to everyone? Just reply in chat box. I need your replies. Everyone, सबको रिप्लाई करना है।